Hello, friends. It's me, Mish. I'm a gremlin today. How is everyone doing? Hello, Jenny. Hello, McCall. Hello, Mika. I hope I'm saying that right. Mikaela Cog. Hello, ABSP. Welcome, one and all, to the Mish stream. How are you all doing? I hope you enjoyed the music and my new starting soon screen. That is music from the Ace Attorney game, Miles Edgeworth, Ace Attorney Investigations 2 from 2011. And oh boy, that music did not need to go as hard as it did, but I'm glad it did. And I'm glad you're all here this evening. How are you all doing? Give me your favorite emotes in the chat. Yes, AVSP, Edgeworth, Miles Edgeworth, your rival from the first game, has his own kind of spin-off series of 2 games. I absolutely loved it. I finally finished playing the second Ace Attorney Investigations. It might be my favorite game out of the entire series, and I've played basically all of them at this point. It is... okay. I talk a lot about, like, you know when you watch, like, a show in an anime, they have, like, the power creep, you know, like, the villains keep, like, the big bad evil guy needs to keep getting, like, bigger and badder to, like, keep it interesting. Like, this game, like, the Ace Attorney games, like, they start out kind of, like, grounded in reality. It's, like, the first game is, like, oh, man, your friend is, like, falsely accused of murder and you have to defend him in court. But then it's, like, it goes so far off the rails. This game was absolutely amazing. It blew my mind. Problem is you need to play like 5 or 6 games as like prerequisites or else you'll be like totally lost. Like the plot's not going to make any sense. But yeah, Ace Attorney Investigations 2. Highly recommend it. Also, never got an official US release. So you have to play like the, you know, fan translated version, which is actually very good. But... I wish Capcom would do an official release. Anyway, welcome everyone to the chat. How are you all doing this evening? McCall, I like those Pride hearts. Happy Pride Month, everyone. Alright, so I'm gonna try something new with this stream. I didn't advertise this stream heavily. You know, usually, hello Donna, welcome to the Mish stream. You know, usually I go on Twitter and I like advertise it and I'll go into like all my friends, you know, Discord servers, whatever. Here I just had my one kind of announcement in the Mish Cord, and that was it. This is kind of limited because this is a new experimental stream I'm doing tonight. We got nobody here. Ricanti's not here to bust my chops. Shh, Donna, don't tell anyone. You're gonna scare him away. We might be doing math tonight. We'll get to that in a minute. But anyway, yeah, like I said, I'm trying something new. If this is totally scuffed, then sorry. I don't know. I guess you have to deal with it. What are you going to do? Go find another streamer on Twitch? I don't think so. That sounds doubtful. What is this about meth? Almost as fun as what we're actually going to do tonight, which is math. So, hey, do you remember when learning used to be fun? I do. I actually really used to like to learn, but then, you know, you go to school and it becomes less about, like, learning fun things because, you know, you want to understand how the universe works, and it becomes all about, you know, like, competing for, like, grades or, like, I don't know. When people force you to, like, learn and do homework, it, like, sucks all the fun out of it. Maybe I'm the only one who felt that way, but I'm going to try and... I actually used to be good at math, and I used to like math, and today we're going to learn math together, and it's going to be wonderful, because no one is forcing me to do this. I used to be good at math. Let's see if I'm still good at math, too. Hello, Ivy Mike. Oh, my goodness. Thank you for the sub. Ivy Mike has subscribed for 9 months. Holy moly. Thank you so much for all of your support. You are wonderful. For Ivy Mike and anyone else who might be just joining us now, we're gonna try something new on the Mish stream. We're gonna do some math tonight. I guess hopefully you all can read this. Let me know. I'm trying this new setup here. I got my little I got my like math problem here up in the top left. I got Oh, I'm trying out a new tablet that I got. So I was, I'm not much of an artist, and I've never done anything with like digital art, but I got this drawing tablet just to kind of play around with it. So instead of watching me bumble through like some like classic Zelda game, you can watch me bumble through trying to get this tablet to work tonight. Anyway, we're gonna have fun learning math together. Hey, important disclaimers. The Mish stream, I am not a professional educator of any kind. I offer no guarantee that anything I tell you tonight will be correct or the smart way to solve these problems, but I'm going to try it. We're going to have fun together. The Mish stream is not a substitute for a formal education. I'm just a gremlin who likes doing math, and we're going to maybe have fun doing math together. Oh, other thing I should say, one moment. All right, tonight's problems come to you from the Barron's AP Calculus book from 2020 by Dennis Donovan. So we're gonna do some fun math problems from this. None of them involve like actual like calculus. This is all just kind of introductory, reviewing the basics type things. But I have given credit to my source. We're using only a very small subset of the questions in this book. I'm gonna show none of the, explanations, none of the solutions. I'm doing all that on my own, so we're only using a small number of the problems here. It's my belief and hope that this qualifies as fair use, as educational material. If not, then I don't know. Please don't sue me. I don't have a lot of money. If you're the copyright holder of this material, just ask me nicely. I'll take the VOD down. I'm not trying to start any trouble. We're just trying to have fun and learn some things together. Donna says, I don't remember most of my school life or most of my childhood. Yeah, me neither. I'm trying to make up for lost time now. Anyway, hey, that's enough rambling for me. Let me know in the chat. How is everyone doing this evening? It's wonderful to see you all. Thank you for spending your Thursday here with me on the Mish stream. All right. Also, let me know if you can read this problem, if the text is like readable here. I got everything all positioned on my screen. I can read it. I don't know if you can. That happens when you're a clone and grown in a lab for evil purposes. Oh no. Donna, are you like an evil twin of some sort? All right. So, hey, let me know in the chat if you like math. I feel like when I say I'm going to do math, people always tell me like I hate math, which is like discouraging. I don't want people to hate math. It can be fun. It can be fun in like the same way that like, when you do like a Sudoku and it's like not necessarily hard, but you like get the right answer and it makes you feel good. Anyway, that's the feeling I'm hoping to recapture tonight. Hey, let me know in the chat if you have questions or if you want to talk about math. Backseating is allowed and encouraged on this. I just may not read the chat until after I do this problem. I also realize there's no way I can win here. I'm kind of setting myself up for failure. It's like, if I can't do these problems, it's like, Mish, you knucklehead. And if I can do them correctly, then it's like, well, great job. You've proved, you're as smart as you were in high school, I guess. But we're gonna see how much stuff I remember many years later. You did Sudoku. I didn't know you were. Are you trolling me, Mike? I didn't know you were in jail. All right. So this is the first problem here. All right. So we have this function. Hold on. See, now the chat can like laugh at me try and like figure out how to use this tablet. All right, cool. F of, oh, that's a good looking F right there. Hey, how do digital artists use tablets? I can barely draw a straight line. You had a disagreement with a cop. I'm sorry to hear that, Ivy Mike. All right, so f of x equals x to the third minus 2x minus 1. Okay, so this is the first problem in this like introductory review section here. Oh wait, I missed some things in the chat. ABSP says AP. This is AP Calculus. This book includes both. So for those not familiar with this AP exam, you have two versions of the calculus exam. There's the AB, which is like a subset, and then the BC includes like more additional topics. So we're including the BC material. We're gonna do the fun stuff. We got some parametric equations. We got some polar coordinates. Some things that only appear on the BC exam. Yeah, we're gonna do it all. All right. So this is asking us to find f of negative 2, which I will do right now. So just gotta plug in negative 2 for x, right? Geez, the only hard thing about this problem is me figuring out how to use this tablet. Okay, so that's gonna be minus 2 cubed minus 2, plug in a negative 2 here. And I'm also doing this without my calculator because that would be cheating. It says no calculators allowed for this section. All right, so negative 2 cubed is negative 8. Whoop. Negative 2 times negative 2 is positive 4, because those negative signs cancel out. All right. Minus 8 plus 4 minus 1. So that's negative 4 minus 1. I'm getting negative 5. Chat, am I right? Did anyone else try and do this? ABSP, did you get the same thing? Am I right on this? Hey, Ricanti, welcome to the chat. Ricanti, can we get a shout out for Ricanti? I don't know if shout outs will work. My bot might not be turned on. Hello, Hadron. Welcome, friends. We're doing math this evening. These are not necessarily difficult problems. For anyone who just joined us, we're doing some review problems from an AP Calculus, a book that I had lying around. This is all first chapter stuff, which is, a review of the basic topics, so we're not actually going to be doing any calculus tonight. I'm mostly just here to hang out with my friends and have fun playing with my new tablet and seeing how much math I've forgotten the past X number of years. Anyway, that was just a simple plug and chug type problem. Plug in negative 2, and then you get the answer. How are you, Ricanti? Ricanti, do you want me to make you a cocktail? Should I pause the me stream? Should we do Misha's mixology? Hold on, what are the hard-hitting questions here? Would it be possible to crash a helicopter by shooting a net gun at the tail rotor? Yes, because the tail rotor provides anti-torque. So, you have, without the tail rotor, the whole helicopter would be spinning around. It's like Newton's third law, trying to counteract the rotational forces from the main rotor. But yeah, don't do that. That would be sabotage. All right. Hey, I used to work for a helicopter factory. Anyway, I'm gonna pause this for a moment and go, hello, Kate, welcome. Hey, Ricanti, can we get a shout out for Kate Bloomer, a wonderful VTuber who you should all follow. Oh, and thank you for the bits. That was so sweet. Kate, you're a sweetie. Welcome to the chat. We're doing math tonight. I'm gonna pause this for just a moment, and we're gonna do some Misha's mixology. It won't be as exciting as usual because I won't be on camera to make the drink, but I'm gonna go make a delicious cocktail for my GF and maybe one for me. So please enjoy. Hey, while I'm gone, we'll say, you know what, Kate, you're a first-time chatter. While I'm gone, Kate's in charge. Hello, Ezekiel. Welcome to the Me stream. All right, everyone. I'll be right back. We're pausing this.
Hello, it's me, Recanti. I'm possessing the gromlin. Unlike when Mish possesses the gromlin, I don't know how to do math. I can do whatever I want. Mish is busy making me a beverage. They can't stop me. What are some good math problems we can solve? Let's see if I can do this. All right. Okay, cool. I have it. Oh no, that's not a drawing. Is this what I need? Oh no, I need to go over here. I see. I'm learning how math works. Oh whoa, okay. All right, we're gonna do some math. Here we go. You ready, folks? Oh no, that didn't work. Drawing tools? Yeah, that looks like what I need. All right. Everyone, do you know what this equals? Do y'all know this one? This is a tricky one. Alright, well, y'all were too slow. Hadron, I'm sorry to say, you are incorrect. It is actually 3.
Hello. Good news, everyone. I'm back. Recanti was being a scoocher.
No, I'm being banished.
Get out of here. You can't see it, but I just sent Recanti to the Shadow Realm. Alright, good news, I'm back. Alright, what did I miss in the chat? Hello, Kate. Aw, thank you, you're so sweet. Alright, getting caught up in chat here. Let's see what sort of trouble you got up to while I was gone. Kate, I didn't know you had the power to steal souls. Man, I'm glad I'm on your good side. McCall, how will I ever get funky again if I don't have any soul? Ivy Mike asks, what is the airspeed and velocity of an unladen swallow? Ah, man, I should remember the punchline from that. I know it's from Monty Python. I need to ask you if it's like African or Asian or something. Tell me more about this swallow. Alright. Enough of this. It's time to erase the whiteboard here. Time to get back to the real stuff. African or European, there we go. Alright, we're moving on to the next problem. I've been streaming for 36 minutes and we've done one math problem so far. We're doing a great job. Y'all, I just got back with my beverage. This is the Misha's signature cocktail, the Crowder Sour. Ah, Kate, you're so sweet. Thank you for stopping by. You are the best. Thank you for joining the stream. Thank you for being wonderful. Thank you for the 100 bits. Everyone should follow Kate Bloomer 27. Alright, time to do some more maths. Okay, so this problem is asking for the domain of this function here. So, we know the domain is all the possible values of x for which the function is defined. Which, in this case, means the denominator cannot be 0, because you're not allowed to divide by 0. So, Good night, Kate. You're sweet. All right, I'm gonna attempt to do a thing right here. Wigimus, welcome to the Mish stream. We're doing math. I'm a gremlin tonight. I hope you're doing well. How are you, Wigimus? Okay, so I got to look at the denominator here. X squared plus 1. X squared plus 1 is not equal to 0. Okay. So wait a minute. Wait a minute. I think this is one of those trick questions here, because then this becomes x squared is not equal to negative 1. Right? But x squared is never equal to negative 1, because x squared is always greater than or equal to 0. So I think the domain is all real numbers. I got D. ABSP, am I right? I'm not even bothering to check my answers. Alright, good news. I was right. It's all real numbers. Rick Ante. I probably deserve a D in math here. Alright, we got it right. It's all real numbers. Alright, next problem. This is asking for the domain of this function. So we got g of x equals this thing. So it's one of those rational functions here. So we know in the numerator, we get the square root of x minus 2. And because we're... Ricanti is 3, your favorite number. Alright. So there's two things going on here. In the numerator, we have a square root. And since we're working with real numbers, we know that we can't take the square root of a negative. So x minus 2 has to always be greater than or equal to 0. And then at the bottom, we know the denominator can't be equal to 0. So let me try and do this here. So we're going to do x minus 2. That's an x, right? Half of the stream is me figuring out how to use this tablet. Alright. X minus 2 is greater than or equal to 0. Hello, Ezekiel. Welcome. You want to do some math with us? That means that x is greater than or equal to 2. Okay. And then there's a second part to this, which is the denominator. So we know that can't equal 0. So x squared minus x is not equal to 0. So we can factor an x out here, right? So that becomes x times the quantity x minus 1 is not equal to 0. Okay, so when does this equal 0? This equals 0 when either two of these things you're multiplying together is 0, which means that x cannot be 0 or 1. But that doesn't really matter, right? Hello, Bup! Welcome. I don't know if shoutouts are working tonight. My bot might not actually be turned on. But if I can give you a shoutout, I would. Everyone should follow my good friend Bupchup, a fellow VTuber who streams some awesome games, most of which I have not played. But one of them is Ghost Trick, which is a fantastic game that you should all play, and you should all follow Bup. Bup, do you like math? I used to be good at math. I'm about to find out if I'm still good at math. So I think the second part to this problem is kind of irrelevant, because if x is greater than or equal to 2, you already know it's not equal to 0 or 1. It's always bigger than that. So I'm just going to say, I think this is our answer. Just x is greater than or equal to 2. Which is C. Did everyone get C? Alright, good answer. Good job. The answer is C. Alright, cool. I feel like there should be some kind of we need some stakes here to keep it interesting. There should be either a reward if I get the problem right or a punishment if I don't. I don't know, chat. Think of something fun that we can do. Alright, next problem here. Can't you punch me? You're not just kidding. Oh man, that would be a good punishment actually. Alright, so I'm looking at problem A4 now. This one looks more complicated. Okay, so they give us two functions. We got f of x and we got g of x. And they want us to find g of f of x. So in order to do that, we start with the function... Wait a minute, what? Okay, well, I was about to say start with the function g, and then you plug in f anytime x appears in this function. But g of x is just always equal to 2. So I think g of f of x is just 2. My answer is D. Good news, chat. The answer is D. No math required for this one. It's just D. D. She wants the D. All right, looking at A5 now. Ezekiel, thank you so much for stopping by. It's wonderful to see you. Okay, this is a more interesting problem. So I think this is the same one as last time, but they swapped the f and the g here. So now we have to look at the function f of x, and anytime we see an x, we would substitute in the function g of x, but g of x is just a constant. So anytime we see an x, we just substitute in 2, right? So I'm getting f of g of x. So it's x cubed, which becomes 2 cubed, minus 3 times 2 squared, plus 5. So it's 8 minus 2 squared is 4 times 3 is 12 plus 5. So 8 plus 5 is 13 minus 12 is 1. That's not an answer. No, wait. Hold on. I did forget the 2x. Thank you, ABSP. Alright, we're going to try this again. So this is minus 2x, and we know x equals 2. Plus 5. Hello, Mahadris. Drunk mod reporting for duty. Welcome. I am not drunk, but I'm kind of trying to play catch up. I did make myself a cocktail. Alright, so we're trying this problem again. Huge shout out to ABSP for unborking me on this problem. Alright, so 2 cubed is 8. Minus 2 squared is 4 times 3 is 12. So we get 8 minus 12. Minus 2 times 2 is 4. Plus 5. Okay. So 5 plus 8 is 13, minus 12 is 1, minus 4 is negative 3. Alright, I'm getting C, negative 3. Good news, chat, we got it right. Can I explain the g of f of x problem from the last question? Yeah. This one? Oh, so there was 2, right? It's kind of the same setup. You have these 2 functions. I'll just expand this here so you can see them both, right? Yeah, so it's the same function for both of these for problems A4 and A5. You have 2 functions. There's f of x equals x cubed minus 3x squared minus 2x plus 5. Then you have g of x equals 2, which is technically a function. It's just like a horizontal line. It's not a very interesting function. It's just equal to a constant. So g of x is just 2. So the first problem, A4, says to find g of f of x, right? G of f of x. Alright, so what does that mean? That means you take the function g, and any time in the function g where x occurs, that's your independent variable, anytime you see the symbol x in the function g, you would plug in f of x. But it's a little bit of a trick question, right? Because you look at the function g, and g is just equal to 2. So there's nowhere for you to plug anything in. So it doesn't really matter what f of x is. You can just kind of forget about that. It's just 2. It's always 2. G is always 2. And that's the right answer. So for A4, yeah, the right answer is D. It's just always 2. So A5 is a more interesting problem, right? Because now instead of finding G of f of x, you got to find f of G of x. All right, so what does that mean? It means anytime you start with the function f, and anytime you see the variable x in there, you substitute in what g of x is. But it's a little bit of, it's not quite as easy as the first part, but it's, because g of x is just always 2, it's basically anytime you see the variable x in the function f, you just plug in 2. So that's what we did a minute ago. And then if you do that math, it simplifies to D. I think you just get 2. Or did it equal -3? I can't remember. Somebody clip that. Tell me what the problem equaled. You know what? I could actually just do it again. So to find f of g of x, so we're going to plug in, we're going to start with the function f and plug in 2 everywhere we see x, right? So it's 2 cubed minus 3 times 2 squared. This is the part that I forgot that AVSP caught me on. Minus 2 times 2 plus 5. Right, so that's 8. Pretend that's an 8. Minus 12. Minus 4 plus 5. And that's 1 minus 4, which is -3. Yeah. So 8/5 is -3, which is C. Alrighty. Good questions, class. AVSP, thank you for asking questions. Thank you for making the stream interesting. Alright, next problem. A6. Okie dokie. So f of x is x cubed plus ax squared plus bx minus 3. Alright, don't mind me, chat. You can't see this, but I'm repositioning my windows here so I don't, like, get a stiff neck from looking at my other monitor all night. Okay, so we've got f of x is x cubed plus ax squared plus bx minus 3. Oh, this is actually kind of a cool problem. All right. So it looks like there's a lot of variables here. But you have this function f of x. So x is really your only like independent variable here. A and b are not really variables at all. They're constants that we can solve for, but we don't know what they are right off the bat. So, but they give you, and we don't, without knowing a and b, we don't know the full function f of x, but they give us these points here. So we know f of 1, right? So when x equals 1, the value of this function is 4. And when x equals -1, the value of this function is -6. And hopefully that's enough information to solve for a and b. And then we know that we can get 2a plus b. All right, so let's try this. Actually, I'm gonna sip my beverage and then we're gonna try it. Don't do math drunk. Don't drink and derive. Man. I gotta stop messing up my tablet here. Yeah, for Canty, that's a fair counterpoint. Okay, so we know f of 1. Alright, so f of 1, they're telling us equals 4. Which means we plug 1 in for x, right? So 1 cubed plus a... Hello, 32-bit kid. Welcome. Oh my goodness, thank you for all those bits. Oh my, I love the powers of 2. You just gave me 127 bits total. Thank you, 32-bit kid. As an electrical and computer engineer, I appreciate powers of 2 whenever I see them, and I appreciate you joining my chat. You are gonna love this. It's the powers of 2 all the way down. Heck yeah. You know, for someone who appreciates binary as much as I do, to come out as non-binary must have been pretty strange. Alright, so, where the heck was I? Alright, so we know when x equals 1, this whole function equals 4. So, we're going to plug 1 in for x here, and of course, 1 raised to any power is just going to be 1, so I could probably simplify this in my head, but whatever, we're just writing everything out to be sure. So it's a times 1 squared plus b times 1. How are you, 32-bit kid? How was your Thursday treating you? Did you do anything fun today? I'm glad you decided to join the Mish stream. Minus 3. And this whole thing equals 4. Right? So we can simplify this, because all these 1s as coefficients just get simplified to 1, or you don't really have to bother writing them. So we know that I'm going to try and simplify this and hopefully not mess it up. So we got a plus b, right? And then we combine these terms. So that's 1 minus 3 is negative 2, right? 1 minus 3, negative 2. That whole thing equals 4. So that becomes a plus b equals 6. All right. So that's one equation simplified, but they give us a second one here. We know that f of minus 1 equals negative 6. Right? So f of negative 1 is negative 1 cubed plus a times negative 1 squared plus b times negative 1 minus 3. And that whole thing equals minus 6. Alright, it's the same as before. We're going to simplify this. So we know negative 1 to an odd power is negative 1. Negative 1 to an even power is just 1. Right? So negative 1 plus a This is plus b times minus 1, so that's minus b. Really hope I don't mess up these like negative signs here. Minus 3 equals minus 6. Alright, so just like last time, you combine your like terms, you get a minus b that's minus 4 equals minus 6. So a minus b equals minus 2. Alright, so we got a plus b equals minus... Shoot. I'm going to have to like erase this to make some more space here. Let's see if I can do this without losing the important stuff that I need. Okay, so we've got these two equations, and that should be enough to solve for a and b here. So what we can do in this case, there's a couple of techniques for solving these, systems of equations where you have, two unknowns and two equations here. But there's kind of a shortcut we can do in this case. So I'm just taking these two equations here. Since you've got an a plus b and an a minus b, you can just like stack these on top of each other and add them up. Right, so you stack the a's on top of the a's, the b's on top of the b's. So you add these up now, and that's 2a. So the b's cancel out, because you get a plus b and a minus b, so it's really just 2a equals 6 minus 2 is 4. Right, 2a equals 4, which means a equals 2. Now you can go back to one of these equations here, right? So if a equals 2, a plus b equals 6, b equals 4. Right, so I've solved for our two coefficients, a and b, which is super. Now what the hell is this problem actually asking us to do? It's asking for 2a plus b. Well, if we know a and b, now we can figure that out, right? So 2a plus b is 2 times 2, right? 2a plus b is plus 4. Right, so 2 times 2 is 4, plus 4 is 8. That's what I get. My answer is B, 8. 32-bit kid, is that what you got? Good news, chat. We got the right answer. You weren't doing the math. 32-bit kid. How dare. Well, you can trust me because I did get the right answer this time. Doesn't happen every time, but it happened this time. How dare. Hey, chat, are you having fun doing math with me? Let me know in the chat if you're enjoying doing math. Give me your favorite emotes if you are. Yeah, wait a minute, isn't it? I was saying that it might have been before you got here. It's where it's like, I feel like so many people get this idea of like, oh, I hate math, but it's like, when you're not, I think the reason so many people hate math is because they're forced to do math, like in school. But then it's like, when you're not forced to do it, so many people will do like things like, I don't know, solve like a Sudoku or like, yeah, do like a strategy game where it's like, there's even so many jokes about a lot of these games that are just like, there's like this fancy front end where you'll see like the characters on screen, but it's like behind the scenes it might as well just be like an Excel spreadsheet. Like you're just doing like calculations to try and like min-max everything. And it's like, I don't know. I think it can be fun. School can be a mixed bag. I've been fortunate to have some very good, very dedicated teachers, and then I've also had other situations where, you know, school kind of sucks the fun out of learning. But that's not what we're here to do tonight. There will be no grading, no time limits, no trick questions looking for excuses to like ding you and take off like a point. It's like, no, we're just here to have fun and learn together. All right, next problem. Wiggins says multiple Picross games in your Switch. Nice. All right, which of these equations is a graph that is symmetric with respect to the origin? There's a couple of ways we can do this. If, all right, well, it says for this section we're not allowed to use a calculator, so I'm going to play by the rules here. We could try and draw the graphs for these and then see which one is symmetric. Or I could use, if I wanted to be really fancy, if I wanted to like impress like the actual like math majors here, I could use the definitions here, because a function that has a graph symmetric with respect to the origin is the same as saying it is an odd function, right? So an example of that, right, would be y equals x cubed. Right, this is an example of a function that's symmetric about the origin. It has a graph that looks something like this. Whoop. Whoop. Right. So I think the textbook definition, right, is a function f of x is said to be an odd function, or said to be symmetric about the origin if for any x, right? So that's your x-axis. This is your f of x axis. So for that to be true, for any x, f of x has to equal minus f of minus x. Right? Does that make sense to everyone? It's basically saying you go x units here, and then you go up like y units here, right? It's your f of x. And it's symmetric, right? Because here you go like negative x units to the left, and you go down this number of units, right? So that's why you have the two minus signs. There's minus x, because you're going left, and there's minus f, because you're going down. So I could be fancy and try and solve it that way. I don't know if that would be too much work, though. Hello, Oreo Chimp. Welcome. Aw, you're so sweet to say that I'm pretty, even though I'm not on camera tonight. Yes, AVSP, you are right. So we can eliminate D right off the bat. We know that's not the right answer, right? Because anything with a constant added to it will be like shifted up the y-axis. So if I draw this out, right? So we're drawing here is, we can do process of elimination, right? Because it's a multiple choice question. Aw, you're so sweet. Thank you, Oreo Chimp. So if I were to draw the graph for D, y equals x cubed plus 2. So we know what the graph of y equals x cubed is because I just drew it. But you're basically scooching the whole thing up 2 units here. So it would look something like this. Whoop. Whoop. So we know this is not symmetric about the origin, right? Because, it no longer touches, here's the origin. It no longer touches the origin since you've shifted the whole thing up. So we can not cheat. Cheating is the wrong word. This is a shortcut. We can eliminate D right off the bat. All right, so now we're left with choices A, B, and C. I'm going to try and sketch the graphs here because I think that's like it kind of depends, but I think in this case it might be faster than doing like the textbook definition of an odd function. Oreo Chimp, thank you for the 100 bits. Heck yeah, mathematical. We're having fun learning together this evening. Alright, so we've already eliminated D. I guess we'll just kind of work backwards. Let me look at C now. So C is y equals x cubed plus 2x. Shoot. I'm not sure if I can easily graph that without using a calculator. So let's skip C for now. Alright, next one, B. Y equals 2 times x to the 4th plus 1. So here's what that graph would look like, right? You got your x, f of x. So we know what 2 to the 4th looks like. It's kind of like a parabola, but like even more increasing quickly, right? So it's like, but then because you have the 1 there, the whole thing is shifted up by 1 unit. So B has kind of this shape here. We know this one's not symmetric about the origin again, because anytime you have a non-zero constant that you add there, it's not symmetric about the origin. It's not an odd function. So far we've eliminated B and D. So we're left with A and C as possibilities here. All right, so let me look at A now. This is x minus 1 over x. So we know, because you have an x in the denominator here, there's going to be a vertical asymptote at x equals 0. Right? Maybe not, actually. Shoot, I'm starting to second guess myself. Here's what I think the graph would look like. And again, I'm following the rules here, so I'm not going to use a calculator. I'm not going to cheat. I think the graph would look something like this. I don't know, though. Having that x in the numerator is like throwing me off. So I'm not 100% sure what the graphs look like for this one. So I'm going to go back to the definition here. So the definition of an odd function, which is one that is symmetric about the origin, we're looking for this function f of x equals minus f of minus x. So I'm going to try and do this without drawing the graph. I'm going to try and just do some like globetrotter algebra here. Mahadris, you cheated. How dare. Alright, well, I'm going to try and do this the old-fashioned way, and I'm going to catch up to where you are. I'm going to make myself an old-fashioned, do it the old-fashioned way. Alright, so let me start with a. This is, so we're going to plug in a negative x and see if we get the opposite of the original function, right? Whoa, that's not what I wanted to do. Okay, so that would be negative x minus 1 over negative x. Does that equal the negative of the original function, which would be negative x minus 1 over x? I have a feeling this is not going to work because you kind of distribute that minus sign over there. And that's going to equal negative x plus 1 over x. Did I do that right? I might not have. Alright, let me start over. Alright. Sorry about that, chat. We're going to try this again. So we need to do negative of the whole function, but then also plug in a negative for x. Let's see if this works. Alright, Rakanti thinks she has an answer, but I'm not looking at that. I'm ignoring chat for the time being, so I gotta see if I can do this on my own. So negative f of negative x is you put a big negative sign on the outside here, and we're going to deal with that later. Then we're going to look at the function f, but every time we see x, we're going to replace it with negative x, right? Negative x minus 1 over negative x. So that's equal to x plus 1 over over negative x, which is the same as negative x minus 1 over x. Is that the original function? I don't know, man. I think that's wrong. Well, this is not equal to the original function, so I think A is not the right answer. Let's see if C works. Yeah, Rakanti, it's not just me. I don't know if I'd be better or worse at this if I didn't have that beverage. Alright, we're trying this again with C. So. Four drinks, dang. If I had 4 drinks, I'd be asleep right now. Negative of negative x cubed. Plus 2 times negative x. Right? 2 times negative x. Okay, so, because you have an odd power here, it's going to be negative x cubed minus 2x Then there's a big negative here. So that distributes, so we get x cubed plus 2x. So, all that is negative f of negative x. And does that equal our original function, which is x cubed plus 2x? Yes, it does. I think C is the correct answer. Ricanti, is that what you got? I think C is the one. There's an odd function, which is the same as saying it's symmetric about the origin. Problem A7, my answer is C. Let's see if I'm right. Holy moly, chat. It is C. I was correct. It only took me half an hour to solve this problem intended for high school students, and I got it correct. 4 drinks is hard. I've only had 1 drink, but what you need to remember about me is I am very small. But luckily, I got the right answer, and once again, I have avoided having to play Where's Waldo for the NES. So I'm going to call that a victory. You're in big lady training mode? Explain. Explain what you mean by that, Hadron. Since when have I been small? Since always. You know this. Okay. Oh, man. Wait. Oh, Street Fighter 6. There we go. Yeah, I know the big lady. Okay, problem A8. Let g be a function defined for all reals. Which of the following conditions is not sufficient to guarantee that g has an inverse function? Okay, so here's what I remember about inverse functions. G, the function g of x, right, has a function which we'll call g inverse of x. Right, so you have a function g of x. If you take the inverse of g of x, I think it equals 1. Pretty sure that's the definition of an inverse function. But also, don't assume I'm right, because I might not be. Okay, which of the following conditions is not sufficient to guarantee that g has an inverse function? All right, A. So we got to do a process of elimination here. Yeah, AVSP, you're right. That is how you calculate the inverse function, right? If you have like y equals some function of x, then you swap the x's and y's. I'm gonna, oh man, okay, whatever. I'll just try and go through them in order, and we'll see if I can do this. G of x equals ax plus b, for a is not equal to 0. Okay, so I guess a and b are constants and x is a variable, which is just saying, and since a is not equal to 0, saying that, right, so we're just looking at part A right now. So that would just be like a line. Sorry, let me try and draw a better line there. Man. Right, so that's just like the equation for a line with a y-intercept of B and a slope of A. So I think that probably does have an inverse function. The way you can find like an inverse graphically, right, is you could draw like the line y equals x, and you could find like the mirror image around that. So I think in this case g inverse of x would just be like a line with a different slope. So I'm going to go ahead and say that A does have an inverse function. Right? Which of these conditions is not sufficient to guarantee it has an inverse function? So I'm going to do this. We're going to write all these choices up at the top, right? We're going to do process of elimination. A, B, C, and D. So I think A is sufficient to say it has an inverse, so we'll eliminate that one. Right? Alright, what does this say? B says G is strictly decreasing. Well, we can draw this graphically, right? So there's like a couple things you can do. There's the vertical line test, right? Like if you draw a graph that fails the vertical line test, you know it's not a function. But if you can draw something that fails the horizontal line test, then you know the function is not one-to-one, meaning it doesn't have an inverse, right? I think that's another definition of an inverse function. So if I can draw something that's strictly decreasing, it fails the horizontal line test. It might actually not be possible. Yeah, I don't think I can do this. I think if a function's always decreasing, then you can't draw a horizontal line that passes through 2 points of the function. So I think we can eliminate B. Alright, what does C say? G is symmetric to the origin. I'm not sure about that one. But G is one-to-one. That's like the definition. We know that if a function is one-to-one, right, that means for every... Am I right about this? For every x, there's exactly one y. That's the definition of a function. But if you can reverse that, if for every y, there's exactly one x, then we say the function is one-to-one. That means it does have an inverse. So I think D is wrong. I'm going to say C is the right answer. But now I'm curious if I can draw an example of this. Can I draw something that's symmetric to the origin that... I don't know. I'm going to guess C on this one, but I'm actually not too confident, chat. Let's see if I'm right. Alright, good news, chat. It is C. If G is symmetric to the origin, that's not sufficient to guarantee it's an inverse function, or has an inverse. Oh, shoot, Mahadris, you're right. Because I was thinking... Shoot. Right, because I'm thinking a cubic function always looked like that. But you're saying you could have a cubic function that goes up and then goes back down. Let me see if I could draw something like this. Adris, is that what you're imagining? Something like this function here. Ah, you're right. Okay, so I got C by process of elimination. I was like, A, B, and D are probably not right. But Mahadris has one-upped me and correctly given an example of a function that is symmetric to the origin and it fails the horizontal line test, therefore is not a one-to-one function, therefore does not have an inverse. So kudos to you, Mahadris. Alright, I think I'm going to do like a couple more of these problems before I call it a night here. Oh man, we're getting into the inverse trig functions here. You must be sobering up. I am clearly not. All right. So we've got... actually, before I start drawing anything out here... we get the sine of the arctan of x. So when you take the sine of anything, I'm tempted to say the range is between -1 and 1, right? Because this is what we're talking about. Right? You've got x and y. So the sine looks like something like that. So it's always in the range. You know, the maximum here is 1. Minimum is -1. But the arctan of x. I gotta remember what the graph of that looks like now. So the graph of tan of x, right, is sine x over cosine x. So you kind of get these like asymptotes here. And then, you know, you can, that's just one period of it. You could draw like more. So to find the inverse of that, the arctan, you know, you'd rotate it around the line. Y equals x. So I think it would look something like this. And now you have horizontal asymptotes. Right? Hello, Too Many Cooks. Welcome. We're doing math. Welcome to the Mish stream. So that's the graph of y equals arctan of x. And this horizontal asymptote occurs at sugar. It's because the tangent of x is sine x over cosine x. So when is cosine 0? It's at 90 degrees or pi over 2. So this is pi over 2. Pi over 2. This is negative pi over 2. The arcuate of x. Yeah, we need the Necco arc of x. Okay, so what does all this mean? All this means is we're taking the sine of some value that goes between negative pi over 2 and pi over 2. So sine of pi over 2 is 1. Sine of negative pi over 2, I hope, is negative 1. But because it never quite reaches that, you have these asymptotes. I think that's kind of the trick here, or what they're testing your knowledge of, is that it's not going to be greater than or equal to, it's going to be strictly greater than, right? So here's what I'm getting, the range of f. I'm going to say it's negative 1 is less than y is less than 1. Yeah, it's going to be either A or B, and I think the trick is that it's not less than or equal to, it's just strictly less than. So I'm going with A. Let's see if I'm right. I have good news, chat. The answer is A. Ricanti says, "Ay." My GF turned into the Fonz. Wait, too many cooks. Are you looking at the problem that I just have on screen here? This is A10, which unfortunately doesn't fit nicely here. Maximum value on the closed interval 0 to 2 pi. Alright, so too many cooks says C. Let's see if they're right. Alright. Hold up, you guys are too fast. I didn't even have a chance to read the question yet. So this is saying cosine x minus 1, but then you take the absolute value of the whole thing. Okay, so what does that look like? So graph of cosine of x normally looks like that, but then there's a minus 1 there, so you're going to shift the whole thing down by 1 unit. So this is 1. So now it's going to go down here like this. Whoop. But then you take the absolute value of the whole thing. Which means that anytime it goes negative, you make it positive. Right, so this is 0. That would be negative 1. And here is -2. I think you guys might be right. So you kind of flip it like this. 2. I say 2. Too Many Cooks says 2. Mahedra says 2. I think you guys are right. Let me check the answer. Well, chat, I have some disturbing news. According to the answer guide in the book, is D, pi. I don't think that's correct. I think there might be a typo in this book. The absolute value of cosine x minus 1. Yeah. The answer is 2. It's asking for the x? What? Oh, sugar. Alright, Too Many Cooks. I think you might be right. This is, the maximum value attained by g on the closed interval is for x equals. That's stupid. That's my fault for doing a bad job of displaying this question. I couldn't get it all to fit on the screen here. It is for x equals something. Well, we can look at this together, right? So we know the maximum value of the function g of x is 2. When does that occur? It's here, right? So that's 0. This, when it goes back to 0, you've completed one period of this periodic function, right? So that's 2 pi. Yeah, it's D, pi. Okay, that's my bad for choosing a bad question that doesn't fit on the screen. We're gonna try and end on a happy note here, though. We're gonna do one more problem so that we can get one right and end on that. Jenny Tag, if you were using that pi emote for your answer, then you are the only one who got the answer on the first try. We were all bamboozled by this question that did not fit on the screen here. All right, one moment. Too Many Cooks, let me ask you a question. This is your first time in the chat. Welcome to the Mish stream. How did you discover the Mish stream? We are glad to have you here. You're looking for math tags? That's wonderful. We are here to do math and learn together. Too Many Cooks, let me ask you some more questions. What is your interest in math? I'm just a normal gromlin who loves to learn, and it's been many years since I've been in school, and I'm seeing how much math I remember how to do. I just like it. Me too. I don't really have a particular goal. I'm not a serious student of math. I don't have a desire necessarily to further my formal education. I'm just here to have fun and do some math with my friends. So hopefully this is the correct level of challenge that you are looking for. I'm doing some problems from an AP calculus book, but these are very early examples. We're not even doing calculus yet. We're reviewing the basics here of functions. But if you would like to continue hanging out in the future, I plan to continue these math streams, and maybe we'll get to some more advanced topics later. I feel like I took differential equations in college many years ago, and I feel like that was kind of where I reached the end of my understanding. I was good up through, calculus, even like multivariable calculus, but then diffie-Qs just kind of escaped me. Maybe it's because I didn't have all the prereqs. I should have done more like linear algebra first or whatever. But yeah, I always felt like I had the ability to do it, but I don't know. For whatever reason, I didn't do a great job at the time, so I'm trying to make up for lost time now. ABSP, you have to take it again? Oh, by the way, Too Many Cooks, thank you for the follow. We are honored to have you here in the Mish stream. Oh, you should also join our Discord. I would try and do a Discord, but I don't know if my bot is working at the moment. Well, we tried. Anyway, we're glad to have you here to hang out and do math with us. I'm going to do like 1 or 2 more problems here. ABSP, you failed each course 3 times. I sympathize. I did not fail the course, but I wouldn't say I ever really understood it. But that's not what the Mish stream is about. We're not about... I said this earlier. I said, like, math is fun, but, like, the grading and, like, the pressure of, like, exams where you're put in this high-pressure situation where you gotta solve things with a very tight, like, time limit, and I don't know. We're not about that. We're not here to stress ourselves out. We're here to learn together and have fun. All right, let me do a couple more of these before I call it a night here. Okay, so A11, which of these functions is not odd? So see, I shouldn't, first of all, Too Many Cooks. I'm glad that you're participating in the chat. I got to do a better job of not looking at the chat, because I'm trying to do these on my own without having the answer spoiled. But I think you're right. I think the answer is C. Because when you add a constant here, it shifts the whole function up, right? So you've got right, if this is your function x and y. Sorry, I just messed up my windows here. Someday I'll get better at using this tablet. So the graph of y equals x cubed plus 1. It's going to look something like this, right? So this is not an odd function because it doesn't intersect the origin. If I were to look at the other ones, right, f of x equals sine x, it looks something like this. So that one is an odd function. B, sine of 2x, well, that's going to have the same shape, but just kind of squished or compressed. Ricanti, thank you for the Discord link. Right, if that graph is y equals sine of x, then sine of 2x is just kind of going to look like that. It's like the same shape, just kind of squished. And then D, f of what? Oh yeah, my bad. Someday I'll get this working better so I can display the whole problem here. This is this one this one I have to think about to graph. Oops. Well, we know since there's an x in the numerator, right, it's going to be 0 for x equals 0. And then x squared plus 1, when does, I'm trying to see if there's a vertical asymptote. When does x squared plus 1 equal 0? Never. That's always greater than 0. I don't know. I'm being a little hand wavy here since I'm trying to do this without like a graphing calculator. But we know that as x gets larger, the denominator is going to get larger faster, so it's going to approach 0. So I have a feeling that the graph looks something like this. Too many cooks, am I right? Is that what D looks like? I think that's probably what it looks like. That is an odd function. So regardless, the answer is C. That's the one that's not odd. Yeah, you're right. Okay, so it's... Hold on a minute. I think you need an extra minus there, right? Well, you just said f of x equals f of minus x. That's the definition of an even function. Aha! I'm keeping you honest. Too many cooks. I regret to inform you that because of that mistake, you are now forced to play Where's Waldo for the NES. That is your punishment. No, I'm kidding. There's no punishment here. But yeah, it is a game. There is, in fact, a Where's Waldo game. I played a ROM of it once, and I didn't get it. Hold on, let me just erase whatever I have here. I like that Hadron's like half paying attention to this stream and then comes back every time we bring up the Where's Waldo game. But yeah, here, man, this tablet keeps drawing these weird lines. Right, so an even function, you know, f of x is even if f of x equals f of minus x. Right? So an example of an even function would be like y equals x squared. Something like that. And then an odd function is f of x equals minus f of minus x. That's something, I don't know, we know sine is like an example here, like do. Oh no, we get triggered by those arrows. Why, did I do a bad job drawing them? So, I was telling everyone, like, I am not a digital artist, I'm not an artist of any kind, but I'm using this, like, drawing pad, and I'm not doing a great job. I think, like, the math is, like, not the hard part of the stream. The hard part is, like, for anyone who streamed, anything that can go wrong will go wrong. I'm just trying to, like, avoid scuff. No! You're not going to get me to play Garfield. Alright, you know what? I'm not ending the stream yet because I'm having fun. Alright, next problem. A12. The roots of the equation f of x equals 0. What? Oh, that's just the definition of a root. Okay. The root of an equation. Yes, never stop streaming. It's just going to turn into a 48-hour math stream. I'm going to be so delirious by the end. Okay, so the first part I got confused by, that's just the definition of a root when f of x is equal to 0. So we're saying the roots occur at 1 and negative 2. Right? So let me draw this out. Let me draw you a graph here. What the hell? Okay, so they're saying the roots occur at 1 and negative 2. So the function crosses the y-axis of those two values. I think. So let me draw an example function that could work for this. It might look something like this. Right? This is a function. And they're asking the roots of f of 2x. So I think that would be this graph kind of like compressed. Right? So I kind of wish I drew a simpler graph. Right, but I think it would be the same graph, but because you're multiplying x by 2, it kind of like squishes the thing horizontally. So instead of the roots occurring at x equals 1 and negative 2, I want to say they occur at 1/2 and negative 1, which is a. Too many cooks, am I right? I say a. Chat, I have some exciting news. The answer is A. We got it. Awesome. Alright, we can do a few more of these. You know what, actually, I'm going to skip ahead. I'm gonna get to the real globetrotter algebra here. So this book I'm looking at, this AP Calculus book, includes some topics that are on the BC exam only. So let's see if we can do some, see if we can end the night with some more challenging questions here. Give me a moment. Yeah, so BC had some additional topics. I don't know all of them because I haven't gotten like far enough into this, but I know the chapter I just finished doesn't even get to like actual calculus. It's just like a review of functions and pre-calc and some more kind of foundational basic stuff. But some topics here that were on the BC exam only are parametric equations and polar coordinates. So let's see if we can get one of those problems. I think all these problems start with A, like we just did like A12. I think the ones that start with B are the BC only ones. Yeah, here we go. Maybe. We're doing everything. I don't even care what the AP exam has. We're here to learn math and have fun. So yeah, we're gonna do some of these more advanced topics, the ones that are on BC only. All right, hold on. I skipped to the last chapter. No, wait, too many cooks. Let me ask you, how far does your math education go? I when I was in college, like I said, I took a calculus, then I did multivariable, I did differential equations, which I did not get and would like to learn enough to graduate. Good answer. I think I mostly understood multivariable calculus. Then we got to differential equations, which I think in my case was ordinary differential equations as opposed to partial differential equations. But it doesn't matter because I never fully understood it, and I would like to learn the things that I should have learned the first time around. So that is one of my goals. But I got a long way before I get there because I got to relearn all the things I've forgotten. So we're gonna try and find a couple more challenging questions to end on. Hold on, I'm gonna put up the BRB screen for just a minute while I try and find an interesting problem to do. While I'm gone, Wigamus, if you're still in the chat, you're in charge. Hello, chat. Alright, good news, I'm back. Alright, hold on. I'm gonna actually pause the music here. Hello! We have a first-time chat. Welcome, Dr. Meanfeel. I like your name. You're right about the horizontal compression, but visuals aside, it's all about input. Alright, wait, hold on. I gotta... Dr. Meanfield, thank you for this example. You're gonna have to give my brain a moment to process this. You're doing like this is some like multivariable globetrotter algebra here. I'm doing like one independent variable, f of x. You got f of x, y, z. Let's see if it has a 0 there. Okay, so you've... Wait a minute. Oh, and 4x equals 1. Oh. Huh. Yeah, I see what you mean. I guess I was a little bit lazy there. I was just like... Yeah, I guess my horizontal compression thing might have been a simplification that wouldn't work for, multivariable functions. Huh. That's interesting. I'm like copying your text to like read later. Anyway, welcome to the Mish stream. I am probably more of a beginner student in mathematics. But Dr. Meanfield, we are glad to have you here. How did you discover our stream? I am but a novice student who is trying to relearn the math that they did many years ago back in college. Alright, we're going to try a few more problems here. Just the stream tag. Awesome. Welcome. We're glad to have you. Alright, we're going to do a few more problems tonight. I'm going to see if I can find a problem dealing with... hold on a sec here. I'm going to try and do this one. This is a parametric equation. So A31. Alright, so we've got x of t equals t squared. Yeah, man, that math tag is really paying off. I'm probably the only freaking nerd like streaming on Twitch right now with the tag math. But apparently there's demand for this content. Okay, so we have x of t equals t squared plus 3. And y of t is t squared plus 4. That actually is awesome. I never expected anyone would be browsing Twitch looking for math, but I am so glad you're here. Dr. Meanfield, if you are interested, I plan to do more of these streams in the future, where I will continue relearning all of the math that I have forgotten. We are reviewing the basics here. These are some problems from the first chapter in like an AP calculus book. We haven't even gotten to calculus yet. This is just reviewing functions and some more kind of foundational topics. But my goal is to learn all of the math that I've forgotten since college, and eventually I would like to understand differential equations, because I learned those once, but I never really learned them. I kind of like learned enough to pass the class, and I don't want to like learn math to, get a good grade and graduate college, whatever. I want to learn it because it's interesting. I want to actually understand it this time around. Yes, I'm pioneering the VTuber femboy math streams. Anyway, Dr. Meanfield, Too Many Cooks, thank you both for joining my stream. I am honored to have you here. So yeah, let's get back to learning some math here. All right, so we got y of t equals t squared plus 4. Okie dokie. So, this is going to be part of one of these curves defined below. It's not obvious to me what it is, but let me just try and do some algebra. If I solve for t, I kind of wonder how far that will get me. Right, so we can do t squared equals x of t minus 3. We take the square root of both sides here. I think you gotta do a plus or minus here. One of those things. So then if we try and solve for t for this equation, we get t squared equals y of t minus 4. And then same deal, we can take the square root of both sides. But I think you could have a, right, t equals plus or minus the square root of y of t minus 4. I think that's correct. So now, since we set both of these things equal to t, I think we can set these equal to each other, right? And I'm going to be lazy with my notation, right? Since we're kind of canceling out the t's, I think I can just do plus or minus the square root x minus 3 equals the square root y minus 4. So then we can square both of these and we get, x minus 3 equals y minus 4. Alright, wait, Dr. Meanfield, I don't want you to feel ignored. I'm going to read your comment, but let me I want to try and do one thing on my own before I get any help. But thank you so much. I really do appreciate you being active on this. So just give me one moment here. So this, you could try and do this, right? Like y equals x plus 1. So that's a line, but I have a feeling I did some shenanigans here that didn't quite work. So my first guess is a line, but I don't know. I'm not too confident on this. Okay, let me look at your comment now. You're right, but the two equations also have something in common without isolating t. Huh. Wait a minute. Dr. Meanfield, I think that was actually a really good hint. Hold on a sec. Hold on. We're gonna try this one more time. I'm setting aside this little area here where I can try and do something here. So we got x of t equals t squared plus 3. So if we know x of t is t squared plus 3, y of t is t squared plus 4, I think I did more work than I needed to. Because y of t is equal to x of t plus 1. Right? And now I can kind of do what I did before, right? Y equals... Holy moly! Dr. Meanfield. Dr. Meanfield, you blew my mind. What? Y equals x plus 1. Look at this. It's the same. Alright. Well, now I'm more confident in my answer. I think it's a line. Alright, let's see if I'm right about this. Good news, everyone. I just checked the answer key, and I'm proud to report that it is, in fact, a line. Ah, man. I'm like playing checkers, and Dr. Meanfield's playing like 64-dimensional chess here. Wait, ABSP. Do you want me to try and explain this problem? I can attempt to. While I do this, Dr. Meanfield, if you're still in the chat, let me know. I know you found me through the math tag, but tell me more about yourself and your interest in math. Is this the appropriate level of difficulty you're looking for in a math stream, or are you just like watching me bumble my way through these basic level problems? Good night, Mahidris. Thank you for joining us. All right, so ABSP. I think you were asking for me to explain this problem, so let me see if I can attempt to do so. And as always, my usual disclaimer, I have no formal teaching certification. I'm just a gromlin who likes math and tries to bumble my way through these problems for your entertainment. But if I could try and explain this problem. So, in algebra you'll have a function which will be, you have one independent variable x, right? And then you'll have, it'll either be like f of x equals something, or, y equals something in terms of x, right? But there are some, I won't say functions because they're not always functions, right? But there are some kind of like relationships between like x and y that are not easily described as, y equals some function of x, right? So you could have like an ellipse or something like this, right? Which like you can't, so if this is your x-axis and this is your y, you can't easily write like, y equals like something times x, because, this is not a function, like it doesn't pass the vertical line test. But if you introduce an additional parameter t, this allows you to define a wider range of curves than you would be able to normally with just, y equals f of x. So that's the whole reason they introduce this additional variable t. But then sometimes in these types of problems, they'll throw you some curveballs, or they'll do some like tricky stuff here where a lot of times you can look at something, like y equals like 3x plus 5, is a line, or, y equals x squared plus 2, is a parabola. Maybe it would become obvious if I did more of these problems, but what was I going to say? It might become obvious if I did more of these, but because I haven't, it's just like I look at these and it's like, okay, you have, these two functions, y equals something time in terms of t and x equals something in terms of t, but it's not obvious to me like what this would actually look like, right? And the variable t, by the way, they say t because often it represents time. So you could have like a particle moving through space and it has some, x value at time t, and it'll have some y value at time t, and, that's why they chose that variable and, how to describe this. But it's not always obvious to me, like, what this would be. But So I did a bunch of algebra trying to solve this and eliminate the variable t and get, y in terms of x, and I ended up getting a line. What Dr. Meanfield pointed out that I didn't notice is that there's a shortcut you can do for this particular problem, where if you notice, x of t is t squared plus 3, y of t is t squared plus 4. Well, t squared plus 4 is just one more than this t squared plus 3, right? So you could do all the work that my dumbass did, or you could recognize that y of t equals x of t plus 1, right? Now, I don't know if this notation here is strictly correct, but I just kind of eliminated the t's here, and I got y equals x plus 1, which is, in fact, a line. So A is the correct answer here. You could also do like all the algebra that I did originally, but that's kind of unnecessary. It's a line. Anyway, let me get caught up on chat. Hello, Chloe. Welcome. I am doing math. Chloe, if my shout-outs were working, I would give you a shout-out, but they're not at the moment. Everyone should follow Chloe. She's wonderful. All right, Dr. Meanfield says, I'm a professional industry mathematician. I just like learning in math lab streams and nostalgic about profession. You like to support learners. That is wonderful. We are honored to have you here. And Dr. Meanfield, if you would like to join us for future streams, I want to do more of these and continue learning. And if you follow me and join me for future streams, that would be wonderful. And if not, that's totally cool too. I am just grateful to have you here now. All right, let's try and do a few more of these before we wrap up for this evening. Dr. Meanfield, are there any topics within math that are particularly interesting to you? I am clearly a beginner compared to you, but enthusiastic about learning. All right, we're going to do a couple more of these. I think this group of problems up through A34, 35, these are some topics that are only in the Calculus BC exam, so this is like parametric equations and polar coordinates, and might be like one or two other topics. So let me try and get some of these in before I call it a night. Anyway, I'm not a math professor. It's been many years since I graduated college. I'm just a software engineer who wants to revisit some of the math that they learned years ago, and also some things they maybe didn't learn as well as they could have. All right, next problem, A32. Which equation includes the curve defined parametrically by this? Okay. All right, so we got x of t is cosine squared of t. And y of t is 2 sine of t. Which equation includes the curve defined by this? Hello, friend. NWE Vaultman. I hope I'm saying your name correctly. Welcome to the me stream. We are relearning math together. All right, for those who just joined us, I'm relearning all the math I forgot. These are problems from an AP Calculus book but this is, we're doing the first chapter tonight, so this is a review of the basics, including functions, including, we're doing some parametric equations now, may do some problems involving polar coordinates, some trig functions, kind of the foundational things that if I don't understand, I have no hope of doing the more advanced problems later. All right. Oh boy. Dr. Meanfield, you're very kind for asking. Let me try and do this on my own before getting a hint. So, the thing I'm thinking of off the top of my head, well, let me see if this gets me anywhere. If I look at this equation y of t, we know that y squared of t, right, equals 4 sine squared of t. Yeah, Ricanti, I'm trying to use trig identities, but the only trig identity I remember is that cosine squared of x plus sine squared of x equals 1. So that's why I have a cosine squared, now I'm trying to get a sine squared. That would have been all the hint I'd given. Awesome. All right, so it sounds like I actually am on the right track with this. Yeah, I don't remember a lot of trig identities, but that is the one I remember, so I'm trying to make this work. So we know sine squared of t plus cosine. Oh, come on. So we know that equals 1. So we have a cosine squared and we have a sine squared. And if I could get something that looks like that, I think I'd be in business. Oh, we know cosine squared of t, so x of t. Right? Cosine squared of t, cosine squared of t. Y squared of t over 4. Right? Y squared of t over 4 is sine t. So that plus that equals 1. Man, what is this question even asking? Which equation includes the curve? Okay. Yeah, we could do this. Oh. Alright, so now, if I multiply everything by 4, I could probably get something that looks like one of these answers. So y squared of t plus 4x of t. 4x equals 4. Is that any of these answers? 4x 4x plus y squared equals 4. I'm getting C. Ah, Dr. Meanfield says nice work. Thank you, Dr. Meanfield. That actually means a lot to me. All right. Let me check the answer guide here and see if I'm right. Good news, everyone. It is C. All right. I think I got a few more problems in me here. All right, A33. Find the smallest value of theta in the interval 0 to 2 pi. Oh, man, it's a polar coordinates one. Oh, thank you, Ricanti. Yeah, I considered it looking up identities, but I'm like, nah, man, I know how these problems work. There's only one trig identity I need, and that's cosine squared theta plus sine squared theta equals 1. All right, so find the smallest value theta in the interval 0 to 2 pi for which the rows r equals 2. I never heard it called a rows. Is that what they call polar functions? For which the rows r equals 2 cosine 5 theta passes through the origin. Oh boy. It's just the shape it makes. All right. Well, I have a confession to make, chat. It's been a while since I've done anything with polar coordinates, but let's see how far I get. All right. R equals 2 cosine 5 theta. So instead of the Cartesian plane with the x's and y's, they're going to give us, this is the 0 degrees, this line, right? They're going to give us some angle, theta, and some radius r, and that defines a point here. Okay. So we're looking at the interval 0 to 2 pi. So r equals 2 cosine 5 theta. All right, well, we know, wait a minute. Okay, well, saying it passes through the origin is the same as saying r equals 0, right? Chat, I'm really making this up as I go along. let's just see how far we get. 2 cosine 5 theta. Ah, thank you, Too Many Cooks. Ah, and thank you, Dr. Meanfield. Listen, I'm so glad you both showed up. This is wonderful. Okay, so we're going to say this equals 0. So now the 2 doesn't really matter because we can divide both sides by 2. So we're looking for cosine of 5 theta equals 0. So when does cosine of something equal 0? That happens, hold on. Guess I could try and take the inverse cosine on both sides here. You guys can watch me really bumble through this basic problem. Okay, so 5 theta equals the inverse cosine of 0. Right? I'm repurposing these axes I made up here. Oh man, I never remember what this looks like. So that's the graph of cosine. If I want the inverse, I kind of mirror it around to that. I think that's what the inverse cosine looks like. Alright, hold on a minute. Alright, Dr. Meanfield's giving me a hint. Consider what are the zeros of cosine, and then think about the first question. Alright, that's actually helpful. Forget this. You know what? I'm gonna forget about that. I don't even care if my graph of the inverse cosine was correct. We're gonna... Hello, Yokai! Welcome, we're doing math. Alright. What are the zeros of cosine? The zeros of cosine occur when this graph passes through the x-axis. And that happens at pi over 2 and 3 pi over 2. So that's super. Now what the hell is this question asking me? The smallest value of theta, 0 to 2 pi, for which that goes to the origin. So that occurs when the cosine of 5 theta equals 0. So the smallest value would be here, right? So I think that's just saying 5 theta has to equal pi over 2. Yokai says, Mish, I got a game on sale on Steam back on Sunday. Which game? Alright, so if 5 theta equals pi over 2, and theta equals pi over 10? Is that one of the choices? Holy moly, it is! C, pi over 10. Chat, I have excellent news. That is, in fact, the correct answer. It is C, pi over 10. Dr. Meanfield, thank you so much for the hints. You nudged me in the correct direction without giving away the answer, and I appreciate that. And I appreciate you. I appreciate everyone in chat. All right, I think we're going to do one more problem before we give up for the night. Cassette Beast. Yes, I have seen several other streamers playing that. It does seem cool. Good music. Okay, A34. For what value of theta in this interval do the polar curves... oops. Gotta scroll to see the full problem here. Aha! Alright, so we gotta find the intersection of these two curves. So, I would know how to do this if it were like Cartesian things, right? With your x's and y's. But they're making it tricky with their r's and their thetas. Ricanti says, Omedito. Listen, I can't be learning math and Japanese at the same time. I'm trying to, learn one thing. Okay. So we gotta find a value theta when these two curves intersect. So we got, Man, I keep messing up. Okay, here we go. So the first curve is r equals 3. The second one is r equals 2 plus cosine of something. 2 plus 2. I fudged that up. Okay. So for what value of theta do these intersect? Oh boy. Alright. Chat, here's the fun part of the stream where I pretend I remember how polar coordinates work. Man, this tablet. Okay. So, you have some angle theta and some radius r. So we're going to go 1, 2, 3 units here. 1, 2, 3. 1, 2, 3. 1. So, if r equals 3, that's a circle with radius 3. So really, what we're trying to find is when this curve, 2 plus 2 cosine theta, equals 3. So this problem is actually not so bad. I think I might not even need to draw that circle. And it might not matter. Like, I think that, yeah, I could just cross this out, right? I'm just trying to solve for theta. Let me see what Dr. Meanfield says. Only consider that math has no idea what r theta x. I have no idea what r theta x or y mean. Oh, that's funny. Okay, so I think I'm on the right track then. The r's don't matter. I'm really just, I drew this circle. The circle doesn't matter. This is just algebra at this point. We're just trying to solve for this variable here. So I'm going to subtract 2 from both sides. We get 2 cosine theta. Equals 1, which is the same as cosine theta equals 1/2. And it's on the interval 0 to pi. Right, so that's 0. That's 2 pi. This is pi. So forget about that. We just care about this part here. So this is cosine theta. So when does cosine theta equal 1/2? Well, this is 1. It's going to be 1/2 somewhere over here. Ah, man. Can I do this without a calculator? We know theta equals the inverse cosine of 1/2. Hold on, pi over 2 is here. That's 1 to 0, so it's going to be something less than pi over 2. Is it like pi over 4? I don't know. I'd have to look at a table or like use a calculator. My guess would be pi over 4. Let's see if I'm right. Oh wow, that actually is one of the choices. Might actually be pi over 6. I don't know. Dr. Meanfield, can you do this one without cheating? I feel like this is something you would just have to memorize, right? Like a table of like these inverse cosine values. Ah, man. I don't know my unit circle. I know it is radius 1. You can't see it, but off screen I'm using my calculator here. I did the inverse cosine of 1/2. Gave me 1.047. Thanks, calculator. Is that pi over 4? No, wait a minute. Pi over 4 would be less than 1. It's probably like pi over 3. Aha! It's pi over 3. That's my answer. C, and I'm sticking to it. Time to check if I'm correct here. Good news, everyone. A34. The correct answer is C, pi over 3. And I think this is a good place to end my math stream for this evening. Huge thank you to everyone who joined. Thank you to all my friends for joining me for this lovely math stream. I hope this was fun for you. I know this is different from the usual video games and hot tubs that you see on Twitch, but I had fun doing math. And I might do more of these in the future. I would like to continue learning math. A special thank you to Too Many Cooks and Dr. Meanfield, our new participants on the stream tonight. It was wonderful to have you both, and I appreciate your help. I had fun learning math with you, and I hope it was fun for you too. Alright, hey, don't leave yet, because we're going to raid one of my friends. So please stick around. And if you haven't already followed, maybe give us a follow. This is less of a self-promotion thing and more of a I had fun doing math with you and I appreciated your help and I would love for you to come hang out and do math with me again next time. So why not give us a follow, and we'd love to have you here again. Dr. Meanfield, thank you for the follow. You are so kind. All right, thank you everyone. Don't leave yet. Stick around for the raid. We're going to raid one of my friends. It's happening. Thank you. I'm done. Good night. Bye, everyone.